Hello and welcome to ID Talk, answers from an infectious disease expert. I'm Dr. Sean Elliott, a pediatric infectious disease specialist with Tucson Medical Center, professor emeritus of pediatrics at the University of Arizona College of Medicine, and leader at the Arizona chapter of the American Academy of Pediatrics. This podcast has been created to answer questions from our chapter's members about the COVID-19 pandemic. This is the week of March 1st, 2021. Worldwide, there have been almost 114.5 million cases of COVID-19 since the start of this pandemic, with over 2.5 million deaths. In the United States, the numbers are 28,664,000 as of today, March 2nd, when I'm recording this, with 514,660 deaths. Looking specifically at pediatrics, the most recent AAP report, which comes to us from February 25th, has a total of 3,168,274 cases of pediatric COVID-19, or 13.1% of the total numbers in the United States. This comes out to 4,209 pediatric cases per 100,000 children in the country. And Arizona specifically retains its number 5 spot for cumulative number of cases. That means that we have 129,590 total cases, or 16.0% of the total number. That also comes out to a 7,048 per 100,000 number of pediatric patients. Again, that's birth up to age 20. For the mortality rate, mortalities I should say total, Arizona now is up to 27 deaths related to COVID-19 in patients from 0 through 19. That is second only to Texas, cumulatively, which has 40, and we have now eclipsed New York City, which stays steady at 23. The three of us are far away above all the other states in the country in sheer numbers of both cases as well as, unfortunately, deaths. So today's questions are all about the vaccines, and in fact this is perhaps the most important topic to talk about right now, since we've all seen that the new Johnson & Johnson or Janssen Pharmaceuticals, the subsidiary of Johnson & Johnson vaccine, has been presented to the FDA and was just issued emergency use authorization. So there now are 3 vaccine products available and currently being shipped to Arizona and elsewhere in this country to vaccinate against COVID-19. The first question, very important, what should we know about the new vaccine compared to the others? So this, the J&J vaccine, which is euphemistically being spoken of, is a return to more traditional vaccine approach, i.e. it is a vectored vaccine. What that means is that the J&J vaccine has taken an adenovirus, which is not pathogenic to humans, but does trigger a normal immune response, such as would to any other respiratory virus, and inserted into that adenovirus vector the genetic code for the SARS-CoV-2 spike protein. So one is injected, it is a single injection, intramuscular like the others, but one is injected with the J&J vaccine. One then recognizes the adenovirus as a foreign invader, a pathogen, and triggers an immune response which injects, or I should say ingests, those infected cells, chews them up, processes the antigen, including the spike protein antigen, and drives the vaccine response in that way. So it's basically exposing the human body to the spike protein via a non-pathogenic infection. Important distinction, infection is not disease. Any of us can be infected with viruses at any time, but if we have immune protection, we are hopefully not as likely to develop actual clinical disease from that infection. That's different from colonization. So 3 terms to be exposed to here. The new J&J vaccine harnesses the second, so infecting the human body on purpose, if you will, with a non-disease causing adenovirus, yet the immune response, the human immune response to that adenovirus is going to, among other things, create antibody protection both to that non-pathogenic adenovirus, but also to the spike protein. So that is how the vaccine works. Important other distinctions: it is a single injection versus 2 to achieve its desired efficacy. And as of yet, it is not as on average, highly effective as the messenger RNA vaccines have been, those being Pfizer and Moderna. But some very important caveats. All three have been very successful in preventing development of severe or hospitalized or fatal COVID-19. So, in terms of preventing the worst outcomes, all three vaccines may actually be equivalent. Number two, the efficacy data presented with the J&J vaccine is an average, and it's an average of all the countries participating in the phase 3 studies globally. So that average is 65% total efficacy. If you look specific to the United States, our local, I guess, or national efficacy was closer to 72%. And even that includes all comers. If you look at efficacy against more severe cases versus the mild to asymptomatic, that efficacy rises even further. Another important caveat in why we should not be comparing efficacies between the first two vaccines, Moderna and Pfizer, and the newest one, J&J. The studies done to demonstrate and confirm efficacy were done at different points in time in this pandemic. And the more recent vaccine study, the J&J vaccine, was done at a time when the mutant variants were circulating and gaining significant incidence. So what we're actually seeing is perhaps, albeit a maybe lower efficacy, but that includes some of the resistant variants against which the messenger RNA vaccines are just now being tested. Yes, the messenger RNA vaccines do appear to be effective, but with lower protection efficacy than the 95 and 94% that they listed when they first were presented to the FDA. So rather than doing a head-to-head comparison, I feel that the best outlook is we now have 3 successful vaccine candidates, all of which demonstrate a good amount of efficacy against the current circulating isolates or strains of virus in this country and globally, and which now include a different vaccine strategy, which may allow some people with understandable and perhaps valid questions about new vaccine technology to accept and adopt this newest J&J vaccine. Has the vaccine strategy that J&J uses been used before? Yes, absolutely. It's a very common approach to vaccinology rather than the messenger RNA vaccines, which in and of itself is not new. I mean, that strategy has been studied scientifically for the last decade. It's just more recently come into active play because of the current pandemic. So it may be more possible or easier to inject or offer this more traditional vaccine to those of our patients and families, and eventually we're allowed to, who have questions about the messenger RNA vaccines, saying that the J&J vaccine is a more traditional approach. What about the reactions? Of course, we all worried about the side effects or the injection side effects. Not a huge amount of data on that yet, just because the studies and the data from Johnson & Johnson have not been published. Anticipate they will soon, in the next week or two, in the New England Journal of Medicine in its electronic version. But what's been reported so far are very typical vaccine side effects. Injection site pain, headaches, myalgias, flu-like illness, just like others which have a good vaccine take. So think again of a vaccine reaction similar to, but maybe worse than the annual flu vaccination, but hopefully nowhere near as severe as the Shingrix or the adult varicella vaccine that some of us, self included, have received. And that was a whopper of a reaction as well. All right, so now here's the next question. Now that there are 3 available vaccines, how should I choose which one is best for me and for my patients? Well, that's going to be a personal choice, obviously. Part of it is going to be based on availability, and although the J&J vaccine was just approved, its manufacturing process is just now tooling up to prepare and then distribute the needed numbers of vaccines. It's going to be a while before we see the J&J vaccine in any significant numbers delivered to Arizona or actually the rest of the country. The other part, though, is the vaccine process is much speedier in the messenger RNA vaccines. It's since the initial platform was created, tested, and rolled out, it's really a matter of just like as many factory spots as are possible to churn out the messenger RNA vaccine, they can churn out doses very rapidly. Versus the adenoviral vector, which means that you have to grow up the virus first, and that takes time, days rather than minutes. So there's going to be a time delay just in the manufacturing process, which will limit the number of J&J vaccines which we see and then are able to decide to administer. However, once all three vaccines are available, how do we decide between them? I think that there will be those who have those questions I mentioned before about the messenger RNA vaccine technology who may prefer a more traditional vaccine. There will be those families that have decreased access to care in whom a single shot regimen is going to be preferable. And there will be certainly those families that come in with vaccine hesitancy. And again, a one and done approach may be more expedient in getting higher vaccine coverage. Ultimately, though, I think we'll find that while not directly comparable, that any of the three vaccines, if it's in the office or in the vaccine site and able to be delivered, is a valid vaccine to administer at this time to reduce the pandemic. The next range of questions moves from the vaccine choices into the impact of those mutant variants. And the question is specifically, with different variants appearing in the United States, do I anticipate many booster coronavirus vaccinations? Yes and no. The booster vaccines that are already actually being developed by AstraZeneca and by J&J have to do with proven lower efficacy of those vaccines against the mutant variants, and it's the anti-gold standard, if you will. I'm not sure if that's a thing, but I'm making it, so there you go. The anti-gold standard for vaccine efficacy is the South African variant, the B1.351, which has shown the highest degree of genetic variability and the highest infectivity, as well as the lowest efficacy of all the available vaccines globally. So, already AstraZeneca and J&J are working on testing the impact of booster doses of their adenovirus vectored vaccines against the South African variant. The messenger RNA vaccines, Moderna and Pfizer, already have been tested against that strain and found to be efficacious, but with lower percentages. So also Moderna and Pfizer are exploring the possibility of a booster. However, they are also already incorporating a modified vaccine which incorporates the new messenger RNA, or I should say the messenger RNA of the new spike protein of the genetic variant from the South African variant. That already has been incorporated into a new vaccine. Although it's being billed as a booster, it's actually a secondary related vaccine, and that data already is being sent to the FDA. So I guess perhaps that the best overall answer is there's going to be an ongoing explosion of response in the vaccine world against the emerging mutant variants, and whether that comes out as a booster vaccine dose of the same vaccine or an annual vaccine or a biannual vaccine with a modified genetic stamp with different to incorporate the spike protein messenger RNA of different variants, that remains to be seen. We can absolutely anticipate a need, I think, for new vaccinology coming forward, even for those of us who already have been vaccinated. Next part of the question then is, with these variants, do we anticipate a surge in coronavirus numbers? The short answer is maybe. Which I'm sorry is not a very definitive answer, but it really depends on the timing of how rapidly we can vaccinate the global population, not just the United States, but the global population, to reduce the viral load, to reduce the natural selective pressure, which is currently supporting the emergence of new mutant variants. Right now, with the current vaccine products available and new ones being approved all the time, we stand a good chance of continuing to tamp down this most recent surge, both in the United States as well as globally, and not encounter a significant surge in numbers such as we just experienced over the last several months. However, that prediction could change in a heartbeat if we fail to reduce that selective pressure and a new highly resistant or highly refractory mutant variant emerges. So far, that is not so, but it truly is only a matter of time if one is looking at predictive modeling. So the answer is a maybe. Hopefully not. And if we can increase vaccine delivery, increase vaccine production, and be nimble in our response to the current emerging mutant variants, then we should be able to keep the numbers in a general overall downward trend. Yes, there are going to be mini surges, at least for the next foreseeable year, I would anticipate. And that is going to be as environmental changes, like we go from cold to hot, people relax their distancing, which is already occurring in this country, as we react perhaps a bit too cavalierly against the current reduction in numbers in hospitalizations. There will continue to be small surges. The hope is that they will be small surges only, without the attendant increase in hospitalizations and use of hospital and clinic resources. So we shall see. That's the that's the big answer there. The next questions then have to do, since we've been talking about vaccines in general, and we all know that the vaccines currently are indicated for at least age 18, or in the case of Pfizer, for age 16 and up. When do we anticipate coronavirus vaccines for kids younger than 16? Well, the predictions are not awesome, because to vaccinate children under 16 means that we have to acquire and then evaluate safety and efficacy data in children younger than 16. So Moderna and Pfizer currently are recruiting age 12 and up. It's a very slow process. AstraZeneca, which has yet to be approved in the United States, is starting studies in the world for children age 6 and up. But all these recruitment efforts are slow because, as we know, children are a protected entity, if you will. And the safety and validity and recruitment strategies, as well as consent procedures, are a completely different kettle of fish for kids versus adults. So the vaccine studies currently in process and those proposed are having a very slow rollout. It's a very careful rollout, which means that safety and efficacy data are going to be a while before we acquire those. So Dr. Fauci is now predicting that while we may get our adolescents age 16 and up vaccinated by this summer in anticipation of the start of the next school year, it may not be until fall of 21, meaning well into the start of the next school year, that we'll have safety data and be able to vaccinate children down to age 6. So it's going to be a while. Does that matter? Yeah, of course it matters for a lot of reasons. If for no other reason, as we attempt to get buy-in from society, it needs to be that we can say these vaccines are safe for everyone, kids and up, so that we can have those open, transparent vaccine conversations while we're trying to vaccinate everybody. In terms of disease epidemiology, so far it is not the young children, the age birth up through age 10, that are the smoking guns for vaccine transmissibility, but it is the middle school and high schoolers are the ones who currently are not yet vaccinatable. So it does matter, and unfortunately, we have conflicting truths, conflicting realities. So at some point in time, yes, we will be able to vaccinate our kids, but that point is not right now. The next question, I saw a headline stating children won't be able to get COVID vaccine until 2022. I guess that's possible. Of course, I'm hoping that is more of a fall of 21, although, late 21, early 22, it's probably going to be somewhere in that range. The next part of the question is, why does it take so long for the vaccines to be approved when the whole vaccine inertia was created in much less time than that? Well, as I've just described, it's all about recruiting pediatric patients into the safety and efficacy studies. As a reminder of how slow that process is, Pfizer, which was the first vaccine manufacturer to recruit down to age 12, aimed to get 3,000 12 to 18-year-old recipients recruited per week in this country to get to a max total. They hoped of 9,000 to 10,000 patients in the country. It's actually taking more than a month, actually closer to 7 weeks to get those 3,000 recruits. So we're looking at a period of a half year to recruit the numbers necessary for statistical significance to demonstrate safety and efficacy. So that's why it takes so long. It's not a delay in vaccine manufacturing, it's a delay in recruitment into the safety studies. And then finally, when will providers have access to the vaccines in their clinics to offer to patients and their families? I don't have the answer to that question. Right now, as I think we all know, the approach of the Arizona Department of Health Services is to create, empower, and send vaccine doses to specific vaccine sites, which are either state-run or based at the hospitals, the universities, or local county health departments. There are some doses, as we know, that have been delivered to local pharmacies, but those numbers are few and far between. My sense of the priority of rollout is to continue to empower specific sites through county health departments and or the state with or without help of local hospitals and universities, that those will be the principal vaccination sites because logistically it's easier to do it that way. Ultimately, however, the plan, as I understand it, is to roll all those vaccines out to local pharmacies, and then ultimately, and I think the final step will be to physicians' practices. So think of the initial rollout in 2009 of the 2009 H1N1 influenza vaccine. It initially started at huge, focal sites in each county, and then entered into the mainstream of vaccines delivered by physicians' offices. That process did not occur overnight. It certainly did not occur halfway through the pandemic, but it took a matter of 2 or 3 years for that to occur. So I think we can anticipate the same thing here, that we are looking at a general move toward routine vaccination against SARS-CoV-2 as part of the annual flu vaccine and other approaches which we offer. But we can anticipate that occurring not for at least another easily half year or perhaps longer. So those are the questions, my friends. Hang in there. Thank you for listening to ID Talk. Arizona AAP members can submit questions for future episodes to covid@azaap.org. For more information and resources related to COVID-19 in Arizona, or to learn how to become a member, please visit azaap.org. In the meantime, hang in there, stay safe, stay sane, stay passionate. This is yours truly signing out.